Hi students, and welcome to Preliminary Chemistry and the Metals video series. We're just going to have a quick look in this video at two very important concepts but two quite different things, empirical and molecular formulae. So we've started to draw our understanding of concepts such as the mole concept, Avogadro's law, the Gay-Lussac law into our discussion about substances and how they combine in chemical reactions. So what we want to do now is we want to have a look at two very important different types of chemical formulae that we can write when we're representing different types of compounds. The first of these is called the empirical formula. Now, the empirical formula is the simplest whole number ratio in which the component atoms of a substance are combined, and that is using whatever the appropriate symbol is for each type of atom. Importantly, non-molecular compounds such as ionic substances have an empirical formula only. That is, copper sulfate is CuSO4, zinc nitrate is Zn brackets NO3 close brackets 2. What this tells us is that for copper sulfate, for example, we have one copper atom, we have one sulfur atom, and we have four oxygen atoms. And this is the ratio. This is the simplest whole number ratio for the component atoms in the compound. One copper to one sulfur to four oxygens. For non-molecular compounds, the formula mass is the empirical formula mass. So as I said before, if the formula for copper sulfate is CuSO4, then this formula mass is the same as the empirical formula. So this is equal to formula and therefore mass is equal to empirical formula mass. And we now know that I could calculate that by going to the periodic table and looking up the mass of copper, and then looking up the mass of sulfur, and then multiplying by 4 the mass of oxygen, and that will give me the formula mass. So important to remember here that the formula mass is equal to the sum of the atomic masses of all elements in that formula. Now, molecular formula is slightly different, and as the name suggests, excuse me, it applies to different molecules. So where we have molecular substances, and this is substances that are either elements or compounds, and it shows the actual number of atoms of each element present in the molecule. Molecular formula can be the same as the empirical formula, or it can be a whole number multiple of the empirical formula. So if we have a look at the two examples that are given here, the first of these is carbon dioxide. This is carbon to oxygen in a ratio of 1 to 2. That is the simplest whole number ratio, and therefore for carbon dioxide, the molecular formula is the same as the empirical formula. However, for octane, the ratio of carbon to hydrogen is 8 to 18. Now, this is not the simplest whole number ratio. We can divide both of these numbers by 2, and we would get a ratio of 4 to 9. So in this case, while the molecular formula for octane is C8H18, in this case, the empirical formula would be C4H9. This is where we can have difference between molecular formula and empirical formula. But notice that the molecular formula is just 2 times the empirical formula, a whole number multiple of the empirical formula. When we look at molecular compounds, the formula mass of these refers to the molecular formula mass, not the empirical. For example, if we were to look at octane again, if we calculated the formula mass of the empirical formula, we would actually only have half the value that we should arrive at. So when you're calculating substances, you do need to use the molecular formula when you're calculating the mass. And once again, as we said previously, the molecular mass is just going to be the sum of the atomic masses of all atoms in the molecular formula. Now, obviously, where the molecular formula and the empirical formula are the same, we can do these, it doesn't matter which one we use. But where there is a difference between the molecular formula and the empirical formula, that's when, if we're calculating molecular mass, we must use the molecular formula. We'll do some exercises in class and examples in order to reinforce some of these concepts. Thanks for watching.